Assalamualaikum and welcome back to another video. Today we are going to discuss the examples of chapter 7. Here is the example of chapter 7. We are going to discuss some of them. The first is example 2. Here is the code. In the example, uh, first we include the library AVR IO for the input outputs, and then in the main function we define an array of mylist and then declare a variable z, declare port B as output, and then there is a for loop which uh, is when z is from 0 to 10 it repeats itself, and then infinite loop while 1. We copy this code from here and then paste it in proteous. Here here we pasted the code, and now we are going to compile the code. Here you see the code is successfully compiled. Now we run the simulation, and the last value is on port B is shown. Now moving to the next example. In example 4 we are going to discuss next. In this example again we define an array store from -4 to +4 integers, and then declare a variable z, declare port B as output, then for loop which continues repeat from 0 to 8, and we copy this code from here and paste it in proteous and try to check what actually it is doing. Here the library is not copied. Why? See, and compile the code. The code is compiled successfully. Again we are going to run the simulations, and by running the simulations on port B the binary of +4 is shown, which is 00000100. Now moving to the next example, example number 9 that we are going to discuss. And this we include the library, set the 16 megahertz frequency for the CPU, then the delay function. In this code we declare port B as output and uh, add some add 1 infinite times to port B, like uh, at the first instant port B has 0 value and we added 1, it become 1, and then again after 500 milliseconds this cycle repeats infinite times, and we have the result shown on port B. Now moving next to example number 11. In example 11, we declare ports C as input and port B and D as outputs, and we also Here declare a variable temp in the while loop. We load the value of pin C to temp and then check that if temp is less than 100, show the value of temp on port P, else show the value of temp on port D. Control C. Now we are going to copy this code here, compile the code. As the code is most probably compiled, yes, the code is compiled successfully. Now we run the simulations and port D, port P both have 0 value. Port B, port D. There is no value in temp. Both the ports have 0 and bind. Moving to the next example, example 12. In this code, we declare port P, port C, and port D as outputs, and then at port P, there is an AND operation between 35 and 0f in hex, and at port C, the result is shown of the OR operation between 04 and 68 in hexadecimal, and in port D, there is the XOR result of both 54 and 78 in hexadecimals. And then at port B, uh, the binary of 55 is inverted and then shown. And copy the code from here, paste it in. Proteus, compile the code and then check the results. The code is successfully compiled. Now check the results. The results are shown on these 3 ports, on port D, port C, and port B. As port B is used 2 times, so the result that is shown second time is shown here at port B. The inverted binary of 55. Now moving to the next example, example number 14. In this code, we declare port B as output, port C as input, and port D again as output. And in the function, we set a mask to check the fifth bit of pin C, that it is 1 or 0. If it is 1, and the if condition true, and port B, uh, at port B, the binary of 55 in hexadecimal is shown, and if it is not 1, the condition is false, else double A, I mean the binary of double A in hex is shown on port B. Copy code from here and then try to run this code in Proteus. Compile the code. The code is compiled successfully. Now run the simulation. 10101010. This is the binary of double A. The else condition, the if condition is not true, so the else is printed or shown on port P. Now moving to the next example, and this example number is 14. And now the next example that we are going to discuss is example 17. In this example, uh, we declare a variable z, then declare port B as input and port D as output. Then z is equal to pin B, and we enable the last two bits of z. There is or AND operation between these, and then switch case. Case 0, port D is equal to 0. Case 1, port D is equal to 1. Case 2, case 3, like 0, 0, show port D with 0. At 0, 1, show uh, port D the value 1. At 1, 0, show 2. At 1, 1, show the value, the binary of 3 on port D. Now I copy this code from here and then paste the code in proteus. Compile the code. The code started compiling. The code is successfully compiled. Run the simulations. At port D 0, 0, 1, 1, 0, 0, 0, 0 is shown at port D. Now moving to the next example, and this example 17. Moving to the next one, now we are going to check example 25. In this example, we have a sensor and an LED. We define the LED on pin 7 and the sensor on pin 1. The sensor is defined as an input of pin 1 of port B, uh, and the LED is defined as an output uh, defined as an output at pin 7 of port C. Then there is the while loop. In the while loop, if condition pin B and 1 less than sensor. If this condition is checking that if there is high value at the first pin of port B, we are going to on the LED. Else, we are going to off the LED and clear all the values. Let's copy this code from here and run the simulations of this code in Proteus. Compile the code. The code started compiling. The code is successfully compiled. Now here we run the simulations. And as we run the simulation, at the 7th pin, as we discussed, 7th pin is high. The LED is on. The first condition is true. The LED is on. Now moving to the next example. We discussed example 25. Now moving to the next example 27. Example 27. We declared a variable BCD byte and then initialize W with 4 and Z with 7. Declare port P as output. Then there is AND operation between W and the last 4 bits of 4 bits, and then left shift W by 4 bits, then Z. There is AND operation between the last 4 bits of Z, then combine W and Z BCD bytes and load it in BCD byte and show the result at port P with what is stored in BCD byte. Copy the code from here. Control V, compile the code. The code started compiling. Yes, the code is successfully compiled, and I run the simulation, the result of BCD byte is shown on port B. 0 1 0 0 0 1 1 1. This is the binary stored in BCD byte and shown on port B. Now moving next to the next example. The next example is example 30. In this code, the first we include the library, and in the main function now we define an array and load the array with hexadecimal values, and then initialize a variable checksum and declare x variable, then declare port D as output. Then the loop of for loop runs 5 times, and if checksum is equal 0, if checksum the result of checksum is 0 till now, the port D is the binary of G, and if this condition is not true, the port D then show the value, the binary value of alphabet B. Control C. Compile the code. The code is successfully compiled. Run the simulation. Run the simulation now. As we run the simulation, sorry, source code, compile, and now this is the last example that we are going to discuss, the example 34. In this, we define SR pin 3. SR pin 3 declare X variable and initialize REGA. Then in this line, we declare the pin 3 as input of port C, and then the loop runs 8 times in this loop. The REGA shift 1 in this line, the first line, the REGA shift right 1 bit, and in the next line we check the we read the data of SR pin, and then the program ends. This is all the example that we are going to discuss in today's video. I hope that this video going to help you. We have not discussed all the examples, but the necessary ones we have covered. So now this is the end of this video. Thank you for watching. Thank you. Allah Hafiz. Allah Hafiz.